Okay, we're going to use calculus to derive the area of a circle, in other words, a disk. And to do that, what we need to do is a couple things. We've got to take this radius, r, and go all the way around the circle. And to go all the way around the circle, that goes from 0 to 2 pi radians. So our stipulation for theta is that it goes from 0 to 2 pi radians. We're also going to go from inside the circle all the way out to the very edge. So we're going to change the radius from 0 to some arbitrary r. So r is going to go from 0 to some generic r. So we got two things that are changing. So since we got two things that are changing, we're going to have two integrals. So let's set this up. So we got an integral of 0 to r. We have the integral from 0 to 2 pi. R d theta dr. Okay. So I try to color code these so we can keep track of what's going with what. The inners go together and the outers go together. And so we want to solve this. Now, it doesn't matter which one we solve for first. Usually, traditionally, we start with the inner ones and work our way out. But you don't have to. But I think I will just in this case. And since r is going to be a constant for the theta part, I want to go ahead and move it out over here. So to r. And we can even move this out to it. Now, I think I'm going to go ahead and do this and separate those two integrals for the sake of simplicity. Now, these are still all multiplied together. This is all multiplication, so that's still multiplied together. And so if I do this integral, we take the integral of r, we get r squared over 2, and our range is from 0 to our generic r. For this one, we take the integral of d theta, we get theta, and it goes from 0 to 2 pi. And now we're going to go ahead and put these in. So that becomes r squared over 2 minus, well, 0, that means that ends up being 0, times 2 pi minus 0. So the zeros don't really count. They cancel each other out. And that means we're going to take this and put it over here. So the 2 times 2 pi, the 2's cancel out. And we get pi r squared is our area. Well, we could have looked that up and normally use lowercase. So pi r squared is our generic equation. That was for a specific r. But so what's so fancy about that? We could have just looked this up on any table in any book, or most people have it memorized. What's the advantage of using calculus? Well, the advantage of using calculus is that we don't have to go all the way around. Let's say that we want to go from maybe not start at the very center, but maybe start out here someplace and just do that distance. And maybe not even go all the way around. Let's say we just want to go part our way around that circle. That's where this comes in handy, where we don't have to do any type of estimates and stuff like that. We can actually calculate directly. So let's do that for one. Okay, so let's say I want to figure out, instead of this whole radius, I want to go from, let's say that's 1.5 units to 2 units. So I just went this section. And I don't want to go even all the way around. I want to go maybe to here. Let's call that where this angle is pi over 3. And so I'm really looking for, if we trace this on around, I'm really just looking for the area of this right here. that area in yellow. And so to do that, we can still set up the same integral as we did before. And we're going to have ours go from 0 to pi over 3 for that one. And for this one, we're going from 1.5 to 2 units. Whatever that is, meters, centimeters, it doesn't make any difference for our example. So we're going to do the integral just the exact same way we did before. So 1.5 to 2 r dr times the integral of 0 to pi over 3 d theta. So when we do these, this one's going to be theta, so integral d theta is theta, so that's going to be 0 to pi over 3. Over here, the integral of r is r squared over 2, going from 1.5 to 2. Again, we'll multiply these two. And so this becomes 2 squared over 2 minus 1.5 squared over 2 times pi over 3 minus 0. So let's go ahead and calculate this. 2 squared divided by 2 is 2, minus 1.5 squared is 2.25 divided by 2. And this is going to be just pi over 3. So we just take our answer and multiply by pi over 3. So let's go ahead and do that. 2.25 divided by 2 gives me that. And now I'm going to subtract that from 2 and gives me that this is 0.875. And we're going to multiply that by pi over 3. So times pi divided by 3 gives me an answer of 0.916 units, or square units. If you want to leave it in terms of pi, it'd be 0.29, let's call it 2 pi units squared. So you can do this, and this is a great method to figure out how much space that takes up. Tune in again and we'll talk about more topics with calculus and physics. Bye.